So this is the last little section of Chapter 5, formula mass, the mass of a molecule or formula unit. So now we've learned probably more than you wanted to know about chemical formulas. We need to be able to relate these to masses. And so here's the general idea. The formula mass, which is the mass of one formula unit, it's sometimes called the molecular mass, the mass of a molecule. We'll take the number of atoms of the first element times the atomic mass of the first element. And remember, the atomic masses are on the periodic table. So a mass of phosphorus atom, one atom is 30.97 atomic mass units. And so we just basically are adding up the masses of all the atoms in a formula unit or a molecule. So here's an example. Calculate formula mass of dinitrogen monoxide, also called laughing gas. I think we could all use a little bit of that right now. Just...
She's like
nitrogen. So we look at the formula. That's not going to work. We need to choose a different color. How about chalk colored? Here's the formula. N2O, we've got 2 nitrogen atoms. So 2 nitrogen atoms, each nitrogen atom weighs 14.01 atomic mass units from the periodic table. And we add to that the mass of one oxygen atom. So there's one oxygen atom, and it weighs 16 atomic mass units. And 14.01, 44.02. Did I do that right? So one molecule or one formula unit of N2O was 44.02 atomic mass units. Yes?
So when I went to do the homework on this particular, when we were at the formula mass, would you mind showing how to do ferric sulfate, which was the Fe2 parentheses SO4, what is the little script at the bottom? Subscript 3. So
I will do something similar.
Do something similar in regards to when you
So
have
a messy
that
one.
With the parentheses.
How about, let's make something up. It's probably not a good idea. How about something like that?
Okay, works for me.
Okay, so this is iron 3 carbonate. How would we do the mass of this? Well, there are 2 iron atoms, 55.85. And then we look at this guy. And here it's important to understand what we're looking at. So this inside the parentheses is the polyatomic ion carbonate. And each carbonate has 1 carbon and 3 oxygens. The parentheses are like the shrink wrap around this bundle pack at Costco, and then we've got 3 of those. So we have a total of 3 carbons and 9 oxygens. So we have 3 times the mass of carbon and 9 times the mass of oxygen. And then we punch that through in the calculator. 2 times 55.85 plus 3 times 12.01 plus 9 times 16 equals 291.73 atomic mass units. Now, just a quick word about significant figures. Some periodic tables, like the ones that we have that I give you for the exam, have rounded all the masses on the periodic table to 4 significant figures. Okay? And those are the ones, I have a lot of the elements memorized just because I do them so often. And generally 4 significant figures is plenty, and it's not going to limit your calculation. And so most of my examples, I'm going to use 4 sig figs on the atomic masses. If you're using another periodic table, by all means, if you want to, use more, whatever. Like on this periodic table, tellurium 127.60. You don't have to round that, okay? It's fine to use more. Do not round to fewer, okay? So here, chlorine, 35.45. Don't call it 35. That will mess things up. So when we're doing this, we're generally going to have 2 decimal places in a lot of our things here. And so I'm kind of a little bit flexible on the sig figs with the molar masses, or the formula masses. So like on this one, technically we're just adding things up and we should have the 2 decimal places. But if you want to round all of yours to 4 significant figures, I'm okay with that too. And off the top of my head, I'm not sure what Master in Chemistry wants. I think it's going to be a little flexible. It'll maybe say, well, that's correct, but you rounded it different. Is probably what it's going to say. Any other questions? Calculating formula masses is really, really important. Okay, some of the stuff we do, it's like the whole percent abundance, calculate the average atomic mass thing. Yeah, we teach you how to do that. That's not a critical skill for passing the class. Calculating these, we're going to do a lot. And so it has to become like kind of second nature, calculating molar masses. Nomenclature is pretty important. Pretty important. Yeah, I know, that's just not what you really wanted to hear. Okay, so then that's the end of this chapter. And there's a chapter in review slides, which I'll just go through slowly so that my YouTube friends, I have 105 of them now, can look at that if they want to. Subscribers, yes. And most of them are not you.